So trying the live thing just to see if everything works. Let's see. Twitch seems to be okay. Super. And YouTube too. Super. Cool. Welcome everyone. We start in 1 minute. If you haven't created your Aura instance yet, please do so that you can come along. I'm sorry for the leaf blower man outside. That's kind of the common theme if you're doing live stream. It's either lawn mowing or construction going on, or leaf blowers or things like that. So that's common things. Let me know where you're watching from. So always interested in seeing where you're coming from. Hey Shiny, good to see you. From Shanghai. So where are you coming from? I'm in Germany right now. We had elections yesterday, which was very nerve-wracking. And let's see what this holds for the future of the country. Hey Andrew, hello to Taiwan. Good to see you all. Okay. I think without further ado, we want to cover quite a bunch of things today. So let's go. I'm gonna share my screen. And then let's see that we can get going. I'll try to check the chat every now and then to see if there's anything that you want to know. Feel free to ask in between what you want to know, and then we'll go from there. Okay, sharing my screen now. Yes. Okay. Switch this on. Super, perfect. Perfect recursion. Super. So before we get started, just to let you know, if you haven't created your Aura instance yet, so Neo4j Aura is Neo4j managed in the cloud. You don't need to take care of updates, administrations, management, backups, things like that. It's all done for you. Unfortunately for all of us, you can get started for free. So there's an Aura free, perpetual Aura free instance that you can use. For instance, to experiment with some data, getting started with Neo4j, learning Neo4j, building your first small graph project, building GraphQL APIs, connecting with Spring Data Neo4j, with Python, with .NET, with JavaScript, whatever you want. I'll show you in a second, and you basically log in to Aura. It just uses an Auth0 account, so you can log in with Google or other Auth0 providers, and then or via email. Then you have to confirm your email. So, and if you've done that, then you basically get to this UI when you log in. You don't have to put in credit card or anything. You can just get going and say create database, and then you say Aura free, and I say my database name is GDelt project. I don't want to have Iowa, I want to have Belgium, and I want to create a blank database. And I click on create free DB. Then it shows me my password that I should remember, so please copy it and put it into some safe place. Because if you don't have it, you need to either pre-create a database or contact support to reset your password. But for the free instance, it's easier to just recreate a database. So and if I do this, for this demo, I don't do this now. It says creating a database, and this takes roughly 10 minutes last time I checked, which was on Friday. So it takes that's why I already pre-created my other database to not have to wait. But if you do it now, then in 10 minutes, you should be ready to go and continue with us. So today we want to look at the GDelt data. What is GDelt? The GDelt project is a large effort that basically scrapes and accesses and collects all the news from around the planet. It's basically takes several hundred news sources from around the planet, newspapers, publications, journals, and things like that. Ingests all the news and then also analyzes the text, so it extracts entities and people and locations and places and organizations and all this kind of things in lots of different languages, and then makes them all available for users to use. Right? So you can do all kinds of stuff with this data. It's very comprehensive. So today we're only looking at a small subset and a simple version of the data. But if you want to dive into it, there's a lot of stuff that you can do deeper in the data. Okay, so this data is available. There's lots of information in here. So there's an event feed, basically, of news events that are coming in. That's one aspect. And then there's also, because they extract all these entities, you can also do a knowledge graph out of the data. So basically, there's also a GDelt global knowledge graph, which gets all the entities and even emotion analysis in there. So there's a lot of data. If you want to explore this further, there's also like a Google BigQuery endpoint that you can query for the data. So it's very comprehensive, but we won't go into all the depth in there today. But if you're interested, there's a lot of stuff in here, right? So it's an endless source of good information, good data, especially if you look interested in global news, politics, economy, NGO-like topics, and so on. Right. They also started to look at analyzing images that are provided with the news. So it actually extracts additional labels and tags for the news from the images that are shared as well. So there's a lot of stuff in here, including downloads of data sets, 2.5 terabytes, or querying the BigQuery database, or analysis services, which are pre-canned services for certain usages and certain users. So that's all good. And what I want to look at today is the REST API, because they also have a REST API, which is quite nice. Unfortunately, there's not too much documentation on the REST API, so I basically Googled for it and then found found this blog post which announces the REST API. And in the blog post, there are a bunch of quick start examples as well. There's also a documentation page. I just need to... here, no, it's also on this page. So it's all in the blog post, basically. So there's a bunch of examples. So you can basically click on any of these examples and then get something. For instance, you can get an HTML page with news rendered. Oops. This one. With news rendered on the fly on a map, for instance. So for instance, if today I want to look at elections, if I look at elections, then there's these news on elections, basically, right? Asian news. And so this is an HTML endpoint, but it also has endpoints in JSON and CSV and other formats as well. And you can get point data, you can get image data, and other things as well. Okay, please let me know in the chat if there's any questions or anything that you want to know. So this is basically the page. I'll also put it into the chat so you can see it here. If you want to follow along, I also updated the GitHub repository with the links, so you can also find the links in the GitHub repository to come along. And so this is what we're going to use. So basically, what we're going to do is kind of use the REST API to access the data and then turn it into a graph. If you want to have a look at what the data looks like, you can actually use this JSON API endpoint here to just have an example. So you see, so there's GeoJSON, but there's also a JSON, what's the other format called? JSON stream or something like that. former GeoJSON, JSON feed. So if you use JSON feed, not GeoJSON, but JSON feed, then you get basically a feed with one news item per object. Let's see. And then it hopefully, come on. Ah, that works. So in the JSON feed, you have the items with URL, image ID, image URL, title, and content text is empty here. But unfortunately, in this JSON feed data, there's no location data. So there's no latitude, longitude in there, which is unfortunate, right? And that was the reason why I looked at the CSV data. So if I change JSON feed here to CSV, it downloads the CSV here. And if I look at this CSV, then you see that it has location, how many results came from this location, latitude, longitude, URL, image URL, and title in here, right? So it at least has the latitude, longitude information as well. That's what I wanted to access in my Neo4j instance. Okay, so if you have created your Neo4j database, it should look like this. And then you can just say open with Neo4j browser. And hopefully you copied your password somewhere because you need to, when you open it with Neo4j browser, you need to log in with the username Neo4j, and then you put in your password that you copied. So we now have 11 minutes, which hopefully gave you enough time to get your database created. And what I want to do first is I want to use this API endpoint and look at the data that we get back from this, so that we can also then look at what would our data model, or what could our data model look like. Data model is not too difficult, but I just wanted to have a look at this. So what do we have? So we have one topic, in this case it's elections, and then we have the following things. With the title, image URL, and URL, that's kind of the news item, the latitude and longitude of the news as well, and the location, which is kind of here, the higher level location on the country level. There's also, we could also change this to ADM1, which is the administrative thing, and run this again. Then sometimes we get some more detailed information, but it's not really clear when you get more detailed information. So sometimes you get a city, sometimes you get an state, and sometimes you get these kind of interesting combinations, which is basically an Russia 48th whatever administrative unit. So you need to resolve this yourself, so which is also not so helpful. So that's why I stayed with the country. I think you can also put in city, if I'm not mistaken, but I'm not 100% sure. Is there something with city? So there's also a version where you get here comma separated, but then you don't know basically what is what, right? So this is Moscow, the English spelling, Moskva, the kind of Russian spelling, but it could be also the state and then the country. So it's not really 100% clear what it is, and I didn't want to spend too much time on analyzing this kind of location strings. That's why I just used country for the time being. What we're doing here, we're accessing the API. So this is the API URL with this topic. So we just said this elections is my variable name for topic, and I just pass in the topic here into the string, and use load CSV with headers from this API, which loads our CSV and returns each row as a map or object or dictionary, whatever you call it, right? So and then we have always key value, key value, key value. And now we can use this key value object per row to turn it into a graph, right? And to look at the data model, I use arrows, which is a nice graph drawing. Let me just delete this from last time. Nice graph drawing at, so we'll just add a node, which is our topic. And then we have from the topic, we would say we have news. And the topic has a property of, say, name, string. And our news, this is kind of a topic relationship, which points from the news to the topic. And in the news itself, we have the URL, which is a string. We have the title, which is a string. We have the image URL, which is a string. And we have the location, which is a point. And then the other thing that I want to do, I want to also point the news to a country. And the country has a name, which is string, and it has a location, which is a point. Right. So this is kind of my simple graph model that I want to use today, and then this country relationship. And then there's this other CSV that you might have remembered, which is not in the JSON, but in the CSV, which is, where's my browser? Here. Which is location result count. So this is for this topic, for this location, so for this country, and for this, for this country, this is my result count. So what I can say is basically, I can say between the topic and the country, I can create another relationship like this and call it results, and probably reverse the relationship and say on this, I can have a count property, which is an integer. So then that also means where per topic I can store how many results I got from a country as such. Because if you look at the data here, what we get back, it's always the same count per country. So this is Russia, and it's always 95,022 results from Russia as such. Right? So we can, it's always the same per location. Cool. Just let me know if you have any questions. So this is kind of our domain model. Let's take a screenshot of that so I can add it later to GitHub Repository. Super. So this is what we want to do. We want to create a topic node in our graph. We want to create a news node in our graph, and we want to create a country node on our graph based on our data, and use that for our data. So let's do this incrementally. So what we can do is basically we load our data. Let's see how we do this. Here. So this is currently our existing results that we get back, right? So for each of these rows, we can access all the elements. So we can, for instance, say row.title, row.location, and we can return, for instance, row.location result count, right? And row.. So this is an example where we either return these objects or dictionaries here, or we can access individual properties and return them as well. So, right, so you see it's our title, our location result count, and the URL. Right. What we could also do here is we could aggregate per location ourselves. So we can also say return row.location and counts down and see, and then just order by see descending. So it gets everything from that URL for 7 days, right? So this is here the time spent 7 days. And then we can access this and then say, okay, how many news did I get per location? So for Argentina 10, for Sweden 10, Chile 10, and then Dominican Republic, Montenegro, and so on. That many news I got per country. Such. Okay. Let me see if everything is still okay. Hopefully it is. Let me know if it's something. Oh, it's not going well. Cool. So we can already work with the data from the API directly. But of course, what we want to do is now we want to create our graph data from this, right? So let me just copy this up here. And then what we can do is, for instance, we can start with our topic node, right? So we can say topic name is topic. So this is a node that we create, and then we say return T. That means it does the URL, does the request, looks at the topic, and then if the topic does not exist, because merge does a get or create. So if the topic already exists, it just returns the topic. If the topic does not yet exist, then it would create it, right? So which is pretty straightforward. So it just creates the topic. It takes a bit because it just takes all the data in, and this is our elections topic, right? So this is currently a lonely node, not connected to anything. And so we need to do something about this. So the next thing that we would do is create a news. So we say we create the news, and it has an URL, which is row.url, right? So the URL is our unique key for the news item, and we just merge the news on that. So the news is now also a single node, but of course we also want to connect it to the topic. So we say this news has a topic relationship to T. So we basically create the news node, which is kind of a second node here, and then we connect it to a topic via a topic relationship to T. And because we use merge here, we can run the statement time and again, and if the data is already there, it will not recreate it. If we had used the create clause here, then it would have created data time and again, which we don't want, right? So, so we return T and the relationship. So let's try this. So now we should create quite a lot of data. So if you look at the table view here, it also tells us, come on, oh, it was probably a little bit too much for the browser to render. Okay, it said it created 1024 nodes here. It created 1024 nodes and as many relationships, right? With the properties that we set. Here's the URL property on them. So now I can actually, in my graph, over here, can see the data as well popping up. So if I click on this database icon here, then one second. I think my computer is a little bit overloaded by streaming and showing me stuff as well. So I have the topic node, I have the news nodes, and it's 1025 nodes, so one topic and 1024 news nodes, and it's our topic relationship, right? So let me just do this. Okay. Just get rid of this one so that my browser is not overloaded. Okay. Cool. So we can also just return count star so that we know how many rows have been processed. That could be easier. So if I run this again, then it says 1173 rows. There might have been some duplicates, so we got only 1024 relations out of it. Okay, no questions so far. So the next things that we want to do is add the additional property to the news. I'll just steal this from the GitHub repo, so we'll look at this in a second. So there's an onCreate clause connected to merge. So whenever it creates the news, it would set this, but because we already have created this, we just change this to set. So it merges the news, and I just saw there's a typo in there. There's a dot missing with end.title. So if you should probably fix this immediately. End.title. Okay. So it creates the news. It sets the title from the CSV. It creates the location as a point object. So Neo4j has spatial data types, so you can do spatial indexes and distance computations and things like that. So it creates a point data type from the latitude and longitude. Please remember that usually from CSV you get strings only, right? So if I download this here again, return row limit 10. So you see all of these are strings, right? So the result count is a string, latitude is a string, longitude is a string, and of course URLs and so on are also strings, right? So that's something that you need to watch out for. So you need to convert the strings basically into floats, so to create a proper point object, and then the image URL as well. So if I run this again, then our news items will get added the other properties. So if I click on news now, you see now our news item has a location and title and then URL as well, right? So, okay. The image is empty because some of those don't have images. But if you want to see these news, then you can just in the browser, you click on these, and then it opens up the actual news from where it came from. Okay. So this also gives you the means to build an app that then does something with the data as well. Okay. So the next thing that we want to do is basically create a country, so which is, as you can imagine, quite similar. So because we have a country node, a country level data here, we can say row.location is our country, right? And then we connect the news to this country. So this will be a little bit more interesting now. And the other thing that I wanted to do is on create set. When I create a country for the first time, I just want to steal the location from the news. So basically, the first time I create a country, I want to kind of set roughly the location from where the news are, so that I can also geo code the country as well. So run this again. I get now country nodes here. And if I look at this, I see all these country nodes, and now I can say, okay, for instance, let's say for me, for Germany, like Pontus, I have these news. And what's interesting, these are actually not in German, but they are probably related to the country. So it's not necessarily what the where the location, what the news is about, but where the news was posted, the country, but which country the news is about, as such, right? Which is interesting. So, for instance, here's Iran, for instance. You can look this up, or if you say something like China, you see these news. So you see also Russian and Arab news, and this, I think, Korean news as such. And so you have all the different countries where we have gotten news for. Okay, and the last thing that we wanted to create is basically this result count, which we basically say 9. We just create a relationship called results between the topic and the country, and then turn this into the result count field, or put the result count field on this one. So that means we, from the topic to the country, we create a results relationship and set the count on this results relationship to the location result count. Right. So, and this is then our whole data set, and we can start to explore this in other ways. Right? So currently we have one topic, elections, but now that we have the statement here to create all our data, we can also say, okay, we don't just want to have this for elections, but we want to have this, for instance, let's say for climate, for USA, for China, for instance, Taiwan, and then we want to do, for instance, another one for Corona. So now we have not just one topic, but each of these topics. And now we can also see what is the overlap of news over those, right? So are there, for instance, now we can ask, okay, are there any news that are related to more than one of those topics? So I'm not sure if that works, but what we can do is basically we can say, so first of all, we can probably have a look at some of those. Let's see, if you look at the topic relationship, this is the elections one. Probably. Let's see if we can, for each topic, we can get, let's say 5 of them or something like that. T, and we just say for each topic we get all the news, and we only want to have, let's say, 5 or 10 per topic. Right. Actually, it's not 20 news, but what we can do, actually, we can assign this to a path, and the whole expression topic to news with the relationship, and then we just get them into a collection and take 10 of them. Take the first 10 from this collection. So we get, for each topic, we take all the paths here, and then we just pick the first 10 and return them. Okay, and I probably did the relationship in the wrong direction. Yes. Yeah. So if you now look at our graph here, you see each of the topics and then the news related to that. Right. So probably, I think there might not be so much overlap. I just realized perhaps you should add vaccine as another topic here that we want to pull. So now what we can do is actually to say, if we want to have news that span 2 topics, we can just express this into as a graph pattern. So for instance, we can say we have the topic to the news that we just saw here, but then we want to also see this news in another topic. Right. So I want to have news that are spanning 2 topics, and then we return our path again, which kind of covers all 3 nodes and 2 relationships. And let's say limit 20. Let's see if we got some news which is then to topics. Here. It's actually quite nice already to see, right? So we have topics that cover climate in the US. So for instance, heat waves, warm waters, vaccine and climate, with Dreamforce and Dreamforce, both vaccine-related and also climate, with the Trillion Tree campaign pledge from Mark Benhoff. Caribbean have COVID and climate topics at the same time. Elections, Germany, climate, because we had a climate election basically. Greta was here in Berlin, Greta Thunberg. So these are the news about this. So you see that there are news covering multiple topics, or China and elections, and then China and climate, right? So I think the Chinese government announced that they don't want to build coal plants outside anymore from now on. So there's covering multiple topics, and this is basically one of the powers of the graphs, that with a single expression you can basically explore more complex structures as such. But it's actually really nice. Let me take a screenshot of this one. You can add it to the repository as well. Right. So this is really just scratching the surface. I'm a little bit sad that this API does not return any of the enhanced NLP entity extraction data, but I couldn't find any way of from that API getting entity data. So you can provide time spans and images and point information and heat map things and so on. But there was no means to get any entity data, which is a little bit sad. So I couldn't find any entity data in here. But the other API, so for instance, if you connect to Google BigQuery and extract the data from there, then you get all the entity data, but it also gets more complex because it's a lot of classification, and so you have to introduce several levels of data to get into that. So that's why I'm not covering this today here. Okay, I think that's almost it what I wanted to show today. Any questions from any of you? Any topic recommendations for topics we could query for from GDelt? So we had a bunch of interesting topics already, but I think if you have any ideas what else we can query for. But basically what I wanted to show you is kind of how to get started with Neo4j Aura free, how to connect to your database, and how to get your data visualized and queried a little bit. Of course, if I wanted to now query what we said before, for instance, I want to see per country how many news have been there, then I can just return the countries and say, for instance, I want to return the size of how many country relationships are there, right? So I would return the country name. I would match all the countries in my graph. So match, find the pattern in the graph, in this case, my countries. I return the country name, and then how many relationships does country have from with this type. So it's kind of the degree of the country, right? So, and if I didn't put the direction in the wrong direction, then I can say actually do it like this. Order by news descending, and here I have my news count. So most of the news are about Mexico, Chile, Lebanon, Argentina. So and then I can also drill down into those if I wanted to. So if I for instance say 5, if I don't return c.name, but the host country node, I have two options. I can look at either at the tabular option here. Oh, this is really nice. Now I can copy and paste things to the clipboard. That's cool. So that's a new feature, actually. So that I can copy these elements to the clipboard. I'm not sure why it's not possible for all of them, but it's actually at least a good step in the right direction. And now I have my top 5 countries here, and then now I could explore it and say kind of what news are there about Argentina, for instance, right? So I can see, okay, these are all the news about Argentina and like COVID updates. What else do we have here? More COVID, Cuba, fellow stars, champion peace. So there's quite a lot of different news. As you also can see from the topics, quite a lot of different news from Argentina as such, right? And what you can also do is basically to say, okay, if I have certain titles or so, I could also say I use them to pull more news, right? So what I can do here is also to say, find me all the news. And what's a little bit unfortunate as well in this API, that it doesn't tell me the language. So I don't have any information what language this is in, which is a little bit unfortunate, because that would be nice if I had the means to do that. But what I could do here is I can basically take the title. So what I can do is I can pick the title and split it on space, for instance, right? Way too lower. Lowercase space, split it on space. Or I could even split it on regex with a custom function. Which is epoch. I could split on non-word characters, basically, as word. Then I can take all the words and return me, for instance, the top, let's say, 100 words. Right? So if this works. N.title, not title. Let's see if this works. So, and it seems that, oh, descending, not ascending. Audible counts are descending. So of course, these are the short words which you could filter out. Let's do this with word where our length of word is greater than 2. I think. 3. Size of word is greater than 3. So now we can see what are top words and titles in our news, and we could use them as new topics that we query our database, our GDelt database as such, right? So for instance, COVID climate, we already have climate, vaccine, world, Corona, Africa, Pacific. So there might be some that India, Biden, and so on. So we have some of these words that we could extract from the titles, basically, that are most frequent in there. So we could basically incrementally expand our news graph based on existing news or based on a different data source as well, right? So I can also say I have another data source which gives me topics like Wikipedia or something like that, and then I query GDelt from that as well. So there's also quite a lot of, as you can see, quite a lot of more complex text and collection management that Neo4j and Cypher can do. So the sky is the limit here in terms of what you can do. Right. Cool. So it's probably also something that I want to keep for the repository. Cool, that's about it. If you have any questions, so Mike has a question. Does the API show anything like giving query results over time or the time series? Yeah, unfortunately, the REST API doesn't provide this, Mike. At least I couldn't find anything. The only thing that you can say is, I want to specify like 2 hours ago, up to 2 hours ago, up to 2 days ago, up to 7 days ago. And so I think the REST API of GDelt is not so great. It's good enough for my simple exploration, but I think for real usage, you would probably use the BigQuery things where you have all this information. You have timestamps and topics and items and elements and things like that. So you would take the data from BigQuery and set up a pipeline that queries that and then turns that into your input stream for the graph. And then you could either connect BigQuery directly or via Kafka, so to Neo4j. So Radek has a question about Aura. So Aura is not so different from Neo4j Community Edition, except that it's fully managed. So you don't need to do set up your own hosting. You don't need to pay for your own hosting, and you don't need to manage updates and upgrades and backups and things like that. Yes, that's a good point, right? We should do a session on that compares the operations aspects of Aura as such. Good point. We'll take this into account. Thank you for that feedback as such. By the way, if you want to see what the differences are, there is on the pricing page for Aura down here, there's a comparison chart for what's included on the different levels of Aura, both in terms of security features, upgrades, backups, and things like that, availability, support, and so on, encryption, and so on. So there's these kind of things are here and also described in this aspect as well. So there's more to it. So the free tier, of course, is kind of just to get started. But then in Aura Pro, it continues to kind of increase in terms of operational features. And then Aura Enterprise for production systems, basically, as such. But it's a really good point. So we'll do a session on that. Cool, Mike. Let us know how it goes. Feel free to drop us a line either on Discord. So you can go to Discord GG/Neo4j to say hi there, or to community.neo4j.com, which is our forum, to share. Would love to hear what you see. There's also a repository from a colleague of mine that I can share in the chat as well, where he started already to look into that as such. So he uses, I think, Spark, if I'm not mistaken, for extracting the data, and uses the BigQuery JDBC driver to connect to BigQuery and then pull the data from there. So, Mike, if you want to explore this, feel free to have a look. Cool. Then thanks a lot for your time, and I'll add the screenshots that I took and the queries that I did to the GitHub repository. So check this out and let us know. Also, if you have other ideas for sessions and data sets and topics that we could cover in the Discover Aura free sessions as well. Cool. Thank you all, and have a great day. Talk to you soon. Bye-bye.